Hey guys, I am making a video going over Lagrange multipliers to help find the min and max values of a function across a certain region or restriction. Um, in this case, we have this f of x value, this f of x y equation of x squared plus xy plus y squared, and and we have to find the min and max value of this equation within the region of this circle, x squared plus y squared equal to 50. So in order to do that, we must find a few equations within to match up the number of unknowns that we have. But it starts with this equation: del f equals to lambda del g. One thing that I want to point out is I never know which direction my lambda is supposed to go. So just point of information. So when we do this del f equal to lambda del g, we're making two equations doing this. It's because we only have x and y. If we had z in this, then we'd make three equations from just this equation here. So in order to find del f, we would just find f of x I and f of y j. So it'd be 2x plus y I plus x plus 2y j, and this would be equal to lambda. And this, since we can say that this x squared plus y squared equals 50, we can say this 50 equals some g of xy. So that's where this del g comes from. Since it's equal to a constant, we can make it equal to some function. So when we do this, we're going to get 2x I plus lambda 2yj. Alright, so we have to set up two equations from this. We'll set up an I equation and a j equation. The reason why I do that is because you can only combine your i's and your j's together. There's nothing that's going to allow you to add your j component to your I component because they're perpendicular to each other. So from the i's, we'll have 2x plus y equal to 2x lambda. For your j, we have x plus 2y equal to 2y lambda. So now we need a third equation in this mix. Since we have this lambda, some coefficient that goes along with our del g that we don't know. And this equation comes from g of xy. So our third equation is just x squared plus y squared equal to 50. So lambda is only important for the sake of finding the different x and y values you can plug into your constraint, which is x squared plus y squared equal to 50. Because sometimes you can have different values for lambda and it might give you different values for your x and y from your I and j equations. So it's something to look out for. And it takes a lot of, guess and check with this kind of problem to try to figure out that there's just no one way to figure out all your variables, like to find all your different values. Sometimes it's really easy and straightforward. Sometimes it takes a little bit of thinking. You have to be intuitive about it sometimes, and I know sometimes I can't be very intuitive, but so you have to be able to practice. It's a good thing I have the answer key right next to me, or else I would be wasting your all's time for a little bit. So what you would do is, for the I and j equation, you would subtract your common variable and its coefficient to the other side. So what I mean by that is we'll make this y equal to 2x lambda minus 2x, and x equals 2y lambda minus 2y. Because then we can pull out a 2x and a 2y from both of those equations. So then we're left with the lambda minus 1. Woo. So now we can relate these equations and either, solve for lambda minus 1, then plug it in, or just, do y over x and cancel out the lambdas that way. So like you can do this, y over x. So that would equal 2x lambda minus 1 over 2y lambda minus 1. Cancel those out. So you know that lambda cannot equal to 1. That's really only important when you have multiple lambdas. Just keep track of it to make sure like these values actually do work. So now we can relate x and y and plug it back into this equation, the x squared plus y squared. So we can say that 2y squared equals 2x squared, which we can just then say y squared equals x squared. Or we can say y equals plus or minus x. Either way works. So this is going to give us an indication that we're going to have, a bunch of different combinations. We're going to have, a plus x minus x along with a plus y minus y. So there'll be about 4 different combinations that we can do for this problem. So when we go back into the constraint, then we'll get that we can plug in x, doesn't really matter. We got x squared plus or minus x squared equals, don't know how that happened, equals 50, which implies x squared equals to 25, because we can add them up together to get 2x squared equals 50, then divide by 2, so we have x squared equals 25, so which gives us a nice number of x equals to plus or minus 5. With x equals plus or minus 5, that implies y equals plus or minus 5. So with this, we have 4 candidates that we can do. We have a positive 5, positive 5. We have a negative 5, positive 5. Then we'll have a positive 5, negative 5. Then we'll have a negative 5, negative 5. So these are 4 different candidates that we have to plug into our original f of x up here at the top. And we just have to plug them in and compare them to find whether or not it's a min or a max value. So odds are with the way that we have a lot of with the numbers both being the same, we have a 5, 5 for all of them, and we have an x, y. Each number is essentially being squared and multiplied by itself. So the numbers with alternating, like it's a plus or minus to positive, plus will probably be a min will be like they'll both be the same thing, and the 2 with the same sign will be either a min or a max. So we'll go plug them in to see what we get. So with f of positive 5, we get 25 plus 25 plus 25, and this is just from plugging in 5 for each x and y to get 75. Now we do f negative 5, positive 5, which equals negative 5 squared is still 25. Plus, so now we have, but in this case, we have a negative 5 times a positive 5, so we're going to get negative 25. And then y squared is going to be, so 5 squared is going to be 25, so this is going to equal 25. Since we have a plus or minus canceling each other out. And so these are, like I said earlier, so since the same sign ones are going to give us one or the other, and the opposite sign ones are going to give us the other one. Like in terms of min and max, we can probably say that this 5 or minus 5 is going to be the same as the minus 5, positive 5, because it's going to be 5 squared. Ooh, my bad. 5 squared minus 5 times 5 plus 5 squared. We get 25, and then the 2 negative ones will give us 75. And this is only just because of how the equation worked out, where we're just multiplying the same numbers to each other. So in order to conclude this problem, we would say that f of x, y, has a max value of 75 at, and we would say 5, 5, and negative 5, negative 5. And has a minimum value of 25 at negative 5, positive 5, and positive 5, negative 5. And it's pretty straightforward for this problem. And after you find out that you can cancel out this lambda minus 1, but sometimes it's not as easy. And I've definitely seen that on a test and just gotten all the points off because I just could not figure out how to relate them. So, on the test, I'd probably, skip this one and do this one last, or just get it set up, then move on to the next problem if you don't see immediate connection or relation. Because this is something that can take up a lot of time if you don't immediately see if you don't make that connection, or you have the intuition to see it at first. Because I know sometimes I don't have it. Or actually, a lot of times on the test I didn't have it, so I end up messing them a lot. But these are big points that can be easily found if you're able to just find that relationship between the all different variables. So, hope this helps. Good luck on your tests. I gotta figure out how this thing pauses. They'll let me pause. I guess not. There we go.